I sin nx. So this is de Moivre's theorem statement. As we know, I is imaginary, and I square value is -1. So this is the thing we have as the statement, and we need to prove this statement by using a standard method. So to prove this theorem, generally everyone is using the method called method of induction. Okay, so we can start our proof. But before start our proof, I just want to give us an input of some kind of a note or an information like this. Why this formula is important? This formula is important because it can be used to solve a lot of trigonometric problems. And we can connect trigonometry to complex numbers using this formula. And another thing is, this formula is not valid for non-integer powers. There are exceptions, but this is the standard or general information. For non-integer powers, this formula will not work. Okay, and now we can start the proof. So the proof is like this. So proof by induction. I hope you know how we can use induction method for proving some statements. So we have a statement, just p of x. Okay, and first we can prove the statement is true for p of 1, and then we will assume this is true for p of k. This is the assumption, and again we will prove this is true for p of k plus 1, or p of k plus 1 is true for this statement. This is actually the general method to prove a mathematical statement. Okay, let me try to start the proof. Okay, we need more space. Okay, so the statement is this: for any integer n, okay, for any integer n, we are going to name the function or statement p of n. This is the function. What is p of n? P of n is cos x plus I sin x the whole raised to n. Cos x plus I sin x the whole raised to n. Okay, so this is equal to cos nx plus I sin nx. So this is what we need to prove. Okay, so we can start out the proof by checking with 1. Okay, so what is p of 1? P of 1 is cos x plus I sin x. So this is true. Okay, here when n is 1, that is cos x plus I sin x. So nothing to prove there. Now we are assuming. Assume. What we need to assume? We need to assume p of k is true for some natural k. Okay, and now we need to prove. So if p of k is true, what will be the statement? That means we are assuming what is p of k? P of k is cos x plus I sin x to the power k is equal to cos kx plus I sine kx. So this is p of k. Name it as equation number 1 because we can use this in the next step. Okay, now so p of k, we assume this is p of k. Now we need to prove p of k plus 1 is also satisfying, or p of k plus 1 is also satisfying all these conditions. So for p of k plus 1 also we can prove the same result. So now p of k plus 1. So what is p of k plus 1? P of k plus 1. P of k plus 1 is what? If p of k is this cos kx plus I sin kx, okay, then p of k plus 1, how can we write it? So this is cos x plus I sin x to the power k plus 1. You know the power of exponent, right? So you know the power of exponent. So we can rewrite this as cos x plus I sin x to the power k times cos x plus I sin x, because that is the rule of exponents. Okay, and we know that what is cos x plus I sin x from equation 1. This is that is cos kx plus I sin kx times cos x plus I sin x. Okay, now just file it. So what will be the result? So I'm writing from here. So cos kx cos x, cos kx cos x, okay, plus I into cos kx sin x, okay, plus again I into sin kx cos x, and I into I square is minus 1, so minus sin kx into sin x. So that's it. Now what we need to do is we need to group it. Okay, we need to group it. Okay, so I terms together, that means so real terms together and the imaginary terms together. So here we have the imaginary term, here we have the imaginary term, so group it. So this is cos kx cos x minus sin kx sin x. Okay, that's the first term, plus I is common, so I into cos kx sin x plus sin kx cos x. Okay, here we need to remember the trigonometrical sum and product formula. Okay, sorry, sum and difference formula. So here this is cos A cos B minus sin A sin B format. Cos A cos B minus sin A sin B. A instead of A we have kx, instead of B we have x. So cos A cos B minus sin A sin B is using the sum and product, sorry, sum and difference formula. We can rewrite this as cos of A plus B. Cos A cos B minus sin A sin B is cos A plus B. So this is cos kx plus x, done, plus I into sin, sorry, I into cos A sin B plus sin A cos B. Sin A cos B plus cos A sin B is sin A plus B. So sin A plus B. So that is x plus kx, whatever it may be. Okay. So from here we can take x common outside. So this is cos k plus 1 into x plus I sin k plus 1 into x. See, that is important. we were actually looking for this k plus 1. So what is this? From where we started it? We started from cos x plus I sin x to the power k plus 1. So cos x plus I sin x to the power k plus 1 is cos k plus 1 x plus I sin k plus 1 x, and this is actually the end of the proof. But before I am concluding this proof, I just want to give a kind of a corollary. So this is the proof. Hence the proof. Okay, so if we have a negative integer, what will be the condition, or sorry, what will happen there? So let it be, so cos x plus I sin x to the power negative n. If n is minus, what will happen? So we can write this, okay, cos x plus I sin x to the power n to the whole power minus 1. That is actually a rule of exponents, nothing serious there. So we know that cos x plus I sin x to the power n is cos nx plus I sin nx to the power minus 1. And by using the previous statements, we can conclude this as cos of minus nx plus I sin minus nx, and hence the result. I hope everyone is enjoyed this video, and I will upload more information about the same theorem with some examples in the next video. So please watch, share and subscribe my channel, and don't forget to press the bell icon to get the next video related to this topic and the topic which is completely related to all math classes. And thank you very much for watching my video all this time.